Automotive electrical. Here's the basics. Ohm's law, voltage, amperage, resistance. Use this triangle to figure out which equation you want to use to figure out what part of the equation you're missing. If you don't have the resistance, voltage divided by amperage. If you don't have the amperage, voltage divided by resistance. And if you don't have voltage, amperage times resistance. In the textbook, intensity, electromotive force, and resistance. So, series circuits. You're going to take all of the resistances and add them together. We only have one, and use that to figure out how many amps. So 12, only one resistor, divided by 2 is 6 amps, right? Easy enough. So if we go and we add another resistor in there at 2 ohms, now we have 4 ohms in total. So that puts us up to a 3 amp, drops the total circuit amperage to 3 amps. Series circuits, nice and easy. Now, that's really easy if you're just running a wire to a light bulb. But what if you want to run a lot of things at once, like on a car? Like a pair of headlights or something like that. We're going to do 6 ohms and 3 ohms. Parallel circuits. Equation is a little more complicated. It's going to be 1 over resistor 1, 1 over resistor 2, and if you have 3, and so on, all added together. So let's do that. 1 over 1 over 6 plus 1 over 3. So that's going to look like 0.166 plus 0.333. This goes on. We're just going to shorten it. So add it together. That ends up being 0.499. Great. That's out it. 1 over 0.499 ends up being 2.004, and this goes on. We're just going to shorten it. So basically 2 amps. Now, one rule with parallel circuits is the total circuit resistance. I'm going to put a little ohm symbol right there. Is the total circuit resistance is always lower than the lowest resistor. So our lowest resistor is 3 ohms. Total circuit resistance is just over 2 ohms. Right? Good stuff. Now, say that's like a pair of headlights. For some reason, they're different resistances. Whatever. What if you got a bad wire in there? Series parallel circuits. Now, a lot of this stays the same. What do we have to do different? So, we're going to add, you still have to calculate the parallel branches all together, and then add in your series circuit after you've got your parallel branches calculated in. So we're going to shorten this just to 2 ohms for simplicity. And we're going to add up to another 2 ohms. We have 4 ohm total circuit resistance as seen right here. Now what about amperage? So if we go back, just to keep this a little simpler, we know that the total circuit resistance was about 2 ohms. So this circuit's going to be drawing 6 amps total, right? But each leg is going to draw a different amperage. As you add more resistors onto a leg, just like a series circuit, the amperage is going to go down. Same with that amperage. But these will have their own. So 6 ohms can be we have 2 amps there and 4 amps there. Nice and easy. But if we have our 2 ohm resistor, all that gets cut down. So now we have 4 ohms total circuit resistance. So instead of that whole circuit drawing 6 amps, it's only going to be drawing 3 amps. So we're going to see half of that here. We're going to see 1 amp and 3 amps. Just draw it out there. Now, hopefully that wasn't too quick. Why is all this important? Well, it's important to understand automotive electrical to diagnose it. To get a basic understanding of what's going on, you can get, you have multiple circuits in a vehicle running at a time from your battery. If you don't understand what's going on inside there, be it a motor, a headlight, resistors for a blow motor, for instance, you're going to have a hard time figuring it out. So in the next lesson, we'll be talking about more advanced components. We have to get a basic understanding of how it all works first.